Every year, over 2 billion cacti are grown around the world. And we are not just talking about your grandma's windowsill plant. They are crushed into cosmetics, tossed into salads, turned into textiles, and even transformed into cactus leather. The largest plantations stretch across thousands of acres in Mexico, Italy, and the United States. These plants grow without a single drop of irrigation, absorb carbon dioxide better than trees, and thrive in places where even weeds seem exhausted. Cacti are charging into the future, and not just in flower pots. In this video, we will show you how they are grown, why the world needs so many cacti, and how they might just help save the planet. In the United States, cacti have long outgrown the souvenir market. They are cultivated for cosmetics, pharmaceuticals, bioleather, livestock feed, and even as an edible superfood. While most people associate cacti with Mexico, it is actually the United States that has become one of the leaders in industrial cactus farming. The United States was not always at the top in this field. Mexico traditionally held that title, where cacti are a national plant, a food source, and a cultural symbol. But starting in the 2000s, when the global boom for superfoods, vegan products, and eco-friendly materials began, American farmers and startups saw a golden opportunity in cactus farming. They figured, quite reasonably, that the climates of Texas, Arizona, and California are ideal for growing prickly pear, nopal, and other species. Plus, the United States has a huge market of consumers seeking healthy, vegan, locally produced goods. So, the demand was already there. Many agricultural startups received grants, investments, or government support to launch sustainable cactus farms. Fast logistics, existing processing infrastructure, and support for small agribusinesses all played a major role. By the 2010s, especially after 2015, farms started popping up not just for food, but for cosmetics, medicine, and leather. And since 2020, when the world embraced alternative materials and zero waste, the United States has stormed into the top producers of cactus-based bioleather. Now, American plantations supply products both domestically and for export to Europe and Asia. The largest plantations are found in Arizona, Texas, California, and New Mexico, regions with dry climates, lots of sun, and very little rain. In Maricopa County, for example, cacti are cultivated across dozens of acres of open land. The main variety here is prickly pear, prized for its fast growth, edible fruits, and industrial applications. It all starts by selecting the hardiest, most productive cacti, those that have shown strong resistance and consistent yields. For instance, a single prickly pear plant can produce 20 to 30 fruits in one season. Farmers cut a segment from the parent plant, usually one pad or shoot, and dry it for 3 to 10 days so the cut seals and does not rot in the soil. These cuttings are then planted in a sandy clay substrate, sometimes directly in open fields, sometimes in containers for rooting. The rows are spaced 3 to 5 feet apart to allow equipment access and minimize light competition. Cacti take 3 to 4 weeks to root, and the first fruits or shoots appear after 6 to 12 months, depending on the variety and climate. During that time, farmers monitor humidity and temperature. Once the first plants are well established, the farm expands by taking new cuttings from these fresh plants. This creates a stable, nearly self-sustaining system. So, it all begins with one spiky stalk, and within a year, it can produce dozens of new ones. To keep a cactus field looking like a postcard-worthy Mexican paradise, it needs real maintenance. Sure, cacti are desert survivors, but once you grow them by the ton, they become a little more delicate than the ones on your windowsill. On a commercial scale, drip irrigation is used, a system of tubes that slowly but steadily waters each plant. The average is 4 to 8 gallons per plant per week, depending on the climate. Next comes pest protection. The biggest threat is not rain, but cochineal. This fuzzy white bug looks like a cute puffball, but drains the sap out of plants faster than you chug a smoothie on a hot day. Then there are spider mites, nematodes, and other microscopic monsters. What do farmers do? They use biocontrol. They release predatory insects to hunt down the pests. It is like Game of Thrones, in bug form. Sometimes they also use natural insecticides, like garlic-based sprays or neem oil. Cacti prefer nutrient-poor soils, but a little boost never hurts. Once a season, farmers add compost or a special blend of nitrogen, potassium, and phosphorus. It is all done by the book, between 11 and 22 pounds of fertilizer per acre. Otherwise, you will end up with a jungle, not a farm. Harvesting on large cactus plantations is not some old guy with a machete. It is a full-blown operation. Harvest usually happens in the morning, before the sun turns the fields into a frying pan. Workers wear protective gear, because those spines are no joke. They trim ripe fruits or pads with special knives, or even mechanized tools. One person can harvest between 1,000 and 1,500 pounds of raw material a day. And if the farm is automated, that number can double. The most popular varieties, nopals and tuna, go on to be sorted. Each plant gets inspected: size, weight, color, and damage. Some fruits are automatically weighed, scanned, and sent down a conveyor. Premium ones head to supermarkets. The rest go to processing or canning. Workers manually inspect up to 1,000 units per hour, so the concentration level is like the final scene of a TV drama. The biggest farms use computer vision systems that sort out defects and count yields. Sorted cacti are packed into boxes or plastic crates, labeled and prepped for shipping. Shipping cacti is all about delicacy and timing. Packed in ventilated containers, they are loaded into refrigerated trucks. The temperature stays between 40 and 50 degrees Fahrenheit to prevent the cacti from turning into mush. On average, one truck carries about 40,000 pounds of product. If it is for export, cacti may travel thousands of miles to Europe, Canada, or Japan. To keep everything fresh, logistics must be timed down to the minute. And a little bit of luck helps. No one wants to open a box of shredded, spiky bits instead of bright green segments. Young prickly pear pads are no longer exotic. In major supermarkets in California, Texas, and Arizona, nopals sit right next to broccoli and romaine lettuce. And yes, they go on sale on Fridays. They are often sold pre-cleaned and sliced into strips, cubes, or thin rounds, or pickled in jars with peppers, garlic, and onions, basically like Mexican pickles. Nopal juice or powder is added to smoothies and supplements. It is good for digestion, helps manage blood sugar, and is considered a superfood. Fried with eggs, cactus is a classic breakfast dish. Think of it like Mexican scrambled eggs with a tangy green twist. It also goes in tacos and burritos, adding texture and a slightly slimy but pleasant acidity. Prickly pear tastes great in salads with tomatoes, feta cheese, peppers, and cilantro. It is also baked with cheese or meat as a side dish, or turned into cactus lasagna. The taste? Well, it is an acquired one. A bit like green bell pepper, a bit like beans, with a slight tang and a slippery texture. If you do not roast it well. But once you try it, you often come back. Do you like the taste of nopal? Share your favorite recipes. If you think cacti are just about spines and sand, you're missing the big picture. They store water in their stems for years. Like real soil-based banks, they hold reserves for hard times. In deserts, they become water distributors for entire ecosystems. Nopal, like many other cacti, is also used in folk medicine for treating everything from diabetes to digestive issues. Its gel helps heal wounds and prevents scarring. In some countries, cactus-based cosmetics are common. Nopal gel is often found in moisturizing creams and serums. Its texture allows it to penetrate the skin quickly without leaving a greasy residue. It is known that nopal extract has a calming effect, helping reduce inflammation from sunburns or skin irritation. The oil extracted from cactus seeds, especially prickly pear seeds, has become a star ingredient in cosmetics. Rich in fatty acids and vitamin E, it is a powerful antioxidant. Prickly pear seed oil helps reduce wrinkles and improve skin elasticity. It also soothes and nourishes the skin, preventing dryness. That is why it is often added to eye creams, where it helps reduce dark circles and puffiness. Cactus extracts are also used in hair products. The oil and nutrients help strengthen hair, add shine, and improve scalp health. They may reduce hair loss and stimulate growth while moisturizing dry scalps. Some cactus-based products even offer UV protection. Extracts can form a natural barrier against the sun's harmful rays, helping prevent sunburn and irritation. Brands like Kiehl's, Fresh, and Herbivore Botanicals already use cactus extracts in their products. Facial creams, serums, shampoos, and hair masks featuring cactus are especially popular. Nopals can live for decades. Some cactus species even live for centuries. For example, the saguaro, the giant cactus, can live up to 200 years and grow to 40 feet tall. That is about 1 inch of growth every year. And it is not just the stems that are edible, the flowers are too. Prickly pear flowers, which often bloom red or orange, can be tossed into salads, brewed as tea, or used as edible decorations on dishes. Every year, thousands of steel frame structures are built on construction sites around the world, not for small homes, but for skyscrapers, bridges, factories, and sports arenas. Today's steel fabrication plants are not just about machines and metal. They are high-tech hubs where heavy-duty equipment pushes its limits. You will find cranes lifting hundreds of tons, robots performing precision welds, and advanced computer systems overseeing quality control. So, how are these structures made? How does the heavy machinery work, and why is every step, from metal melting to final assembly, absolutely critical? You will definitely want to see this for yourself. Steel preparation is the very first and most important step in manufacturing frame structures. At steel mills and factories, the process starts with massive metal stock delivered in the form of steel sheets, rods, or blocks, some weighing up to 50,000 pounds. These materials often arrive in specialized containers that can carry multiple tons of metal, and large overhead cranes, capable of lifting up to 100 tons, are used to move them across the facility. One of the most impressive sights is the lifting and transport of these heavy chunks of metal. The crane approaches a towering pile of steel blocks, grips them using heavy-duty hooks, and with astonishing precision, hoists them to the next stage of production. Crane operators must work in perfect sync, because even a small mistake can cause major damage or a dangerous accident. The metal blocks are usually cut down using industrial shears or plasma cutters. These specialized machines can slice through steel up to 3 inches thick in just 1 second. They create precisely shaped profiles for the next phase of production, delivering perfectly clean cuts that would be nearly impossible by hand. Once the steel has been trimmed into the required shapes, it moves on to the melting stage. This is one of the most dramatic parts of the process, as the steel is heated to over 2,800 degrees Fahrenheit, producing smoke clouds and bursts of flame. Technicians operate powerful furnaces that can process up to 300,000 pounds of metal per minute. They must keep the temperature steady, because even a small fluctuation can change the steel's properties. Once liquefied, the steel is ready to be poured into molds. At every stage of this process, quality control is key. Special computer systems track temperature, pressure, and other vital data to ensure consistency and precision. When the steel reaches its molten state, the next important step is impurity removal. Impurities like sulfur, phosphorus, and other unwanted elements can weaken the metal. To eliminate these, filtration and delivery systems go into action. They use physical filters to attract unwanted particles, or inject chemical agents that bind with them to form slag. The slag rises to the surface, where it can be easily skimmed off. At this point, large gas jets, usually nitrogen or oxygen, are introduced to further purify the steel. These jets are injected through special nozzles that help break down and disperse impurities. Once the steel is clean and cool, it moves to the rolling stage. The remaining molten metal is sent to rolling machines, where giant presses flatten it into long steel sheets. Each sheet goes through multiple rolling phases, with pressure reaching up to 10,000 tons per square inch. The finished sheets can be less than half an inch thick, depending on the needs of the structure. Next comes shaping the individual structural elements. CNC machines and heavy-duty tools cut and form the sheets and beams according to the blueprints. Computer-controlled systems allow for cuts accurate down to the millimeter. Individual elements, like beams, columns, and joints, are shaped and prepared for welding. A single machine can produce up to 500 components per day. Welding and assembly are some of the most impressive parts of building a steel frame. After the metal parts are cut and prepped, they are positioned and joined using arc welding, gas welding, or even laser welding. Heavy metal segments, weighing over 500,000 pounds each, are hoisted by cranes capable of lifting 50 to 100 tons. These cranes maneuver the sections into place using steel cables and counterweights, allowing precise placement before welding. Meanwhile, welders get to work at the center of the operation. They use machines powered by electricity or gas mixtures that can reach temperatures of over 6,500 degrees. These high temperatures allow metals to bond at the molecular level. Welders carefully guide the arc or flame to melt the edges and fuse them. The seams must be flawless, so the process demands total accuracy. After welding, every seam is rigorously inspected. Laser scanners examine the joints for cracks or flaws. Ultrasound checks are also performed to detect microscopic gaps or defects inside the welds. At the same time, other crew members install additional structural elements like beams and support frames, with precision down to the millimeter. Automated robotic systems also play a huge role. These machines position steel components and hold them in place while welders work. Once everything is welded and secured, the final steps begin: grinding and painting the joints for corrosion protection. This finishes the steel frame assembly and prepares it for transport or installation on site. For large-scale projects, this process can take weeks or even months. It is not just technically complex, it is visually stunning. Watching huge steel pieces rise and come together to form new shapes is truly amazing. Structures that must endure extreme conditions undergo additional treatment, like alloying and anti-corrosion coating. This extends their lifespan and keeps them looking good for decades. Zinc coatings or special heat-resistant paints are often used. Stress testing using pressure rigs helps engineers understand how the frame will perform under load. Computer simulations reveal weak points and allow stress to be redistributed where needed. These tests often last up to 72 hours, depending on the complexity of the structure. Finished steel components are transported to the construction site using specialized trucks and carriers. Gantry cranes capable of lifting 200 tons handle these deliveries. At the site, tower cranes and mobile cranes take over, lifting each piece into position. Assembly can take days or weeks, depending on the size and complexity of the project. Attention! Today we have a very special mission: to rescue Private Meat Grinder. This mighty machine makes life easier in countless households, but when it breaks down, a million questions pop up. What do you do with all that metal, plastic, and electronics? Imagine this: nearly 90% of modern meat grinders are made of metal and plastic, which means most of their parts can actually be recycled or reused. There you are, staring down the machine that used to hum happily while turning enemies, meat, into ground perfection. Now you are desperately flipping through the manual, trying to revive what is basically a lifeless pile of parts. Unplug that meat grinder and listen up. You will never know how much you need an electric meat grinder until it breaks and leaves you without one of the most useful kitchen tools. When that day comes, you only have two choices: spend a fortune on a new one, or figure out how to recycle the old one and squeeze some value out of it. Did Baron Karl Drais ever imagine his invention would cause such issues down the line? In the 19th century, he invented a hand-cranked meat grinding machine. Some folks still use these old-school grinders today. Twist the handle, get your ground meat, and work your arm muscles at the same time. But no, you just had to get the fancy electric one. And now you have to figure out how to dispose of it properly. But is there really anything worth saving from an electric meat grinder? It might seem like just another trip to the trash bin, but the truth is, recycling can actually be super valuable. In the United States, the disposal of electric meat grinders, like other household appliances, is managed through specialized electronic waste recycling centers. Even though meat grinders do not technically fall into the traditional electronic waste category, you can still drop them off at locations that accept small household appliances. Many cities operate special household waste collection centers that accept electronics and electric devices. You can usually find information about these programs on your local city government website. Some stores where you bought your meat grinder might also accept old appliances for recycling, depending on their policy. While not always included in official e-waste programs, some organizations will still take them in as household electrical devices. Companies that specialize in household waste management may also accept electric appliances. This service might come with a fee. Before dropping off a meat grinder, make sure to check if there are any specific preparation requirements, like removing hazardous materials. I know you have had that sneaky thought: just toss it in the garbage and pretend it never existed. Then walk into a store and pick out a shiny new grinder that will once again grace your kitchen counter. But hold up. Improper disposal of e-waste in the United States can lead to huge fines, even criminal charges. Fines can reach into the hundreds of thousands of dollars. For example, in New York City, companies that illegally dumped over 1,700,000 pounds of electronic waste were fined more than $200,000. In California, breaking e-waste laws can cost you up to $20,000 per violation, per day. Some violations have even resulted in prison sentences. Executives at a company called Executive Recycling were convicted for illegally exporting e-waste and committing fraud. But why wait for the worst to happen when you can be a part of something better? Something that helps the planet and gives your meat grinder a second chance. When recycled properly, your old electric meat grinder can transform into all kinds of useful things, depending on how it is processed and how creative people get. The metal parts can be melted down to create everything from car parts and building materials to brand new home appliances. This reduces the need to mine for new raw materials and supports sustainable manufacturing. You can even repurpose your meat grinder as a decorative item or something functional. Give it a fresh coat of paint, and it could become a funky kitchen accessory or even an art piece. If the grinder has plastic parts, they can be shredded into pellets that are later used to create new plastic items. Things like packaging or even materials for 3D printing. You can also repurpose it as a shredder for other things, like old soap, turning it into usable pieces or pellets. In some cases, people modify meat grinders to process food waste, helping convert it into compost or biogas. Meat grinders are made up of nearly 70% metal. And anything made of metal can be recycled. If the grinder's housing is made of steel or aluminum, that metal can be melted down and used to make new products. In fact, according to the Bureau of International Recycling, recycled metal is up to 3 times cheaper than newly mined material. According to the European Metal Recycling Association, the global value of recycled metal reaches about 5 billion euros per year. Around the world, 275 tons of plastic are produced every single minute, making it one of the biggest sources of waste. Recycling plastic saves about 60% of the energy compared to creating new material. Some meat grinders have plastic casings or parts, and today's technology makes it possible to recycle that plastic into brand new materials. This helps cut down on resource consumption and protects the environment. At recycling plants, robotic or manual systems separate plastic components from the rest: metal, wiring, motors. Then, powerful shredders break the plastic into small pieces just a few inches in size. These shredders look like giant metal jaws that spin and grind the plastic into pellets. The shredded plastic is sent into hot water baths with special detergents, often alkaline-based, to remove grease and grime. Food bits, oils, dust, and dirt get separated. Dirty particles float while clean ones sink. Clean particles are then dried in large drums or using high-powered air blowers. After drying, the plastic is scanned and automatically sorted by type so it can be sent to the right recycling stream. This entire process takes just a few minutes per batch, but each facility can handle dozens of tons of plastic appliance parts every day. The motor is the heart of a meat grinder. It is made of copper and other valuable metals, and it can be recycled by extracting the copper for reuse in other devices. Electronic components are usually processed at specialized facilities that recover precious materials. Every kilogram of recycled e-waste can contain nearly 2 ounces of gold, which makes it incredibly profitable to process. The large bundles of wiring often found in household devices are made of copper or aluminum, both highly recyclable materials. Copper is one of the most recycled metals in the world, with 90% of copper wires making their way back into production. Once every single part of the meat grinder, from the big metal pieces to the tiniest plastic fragments, has been cleaned, shredded, and sorted, they get directed to special containers. But these are not your average trash bins. They are organized zones, where every type of material has a specific destination. Metal parts, especially steel and aluminum, go into large bins and are sent off for melting. They might be turned into bicycle frames, car parts, or even new kitchen appliances. Copper recovered from the motor is pure treasure. It gets shipped to specialized plants, where it is melted down and becomes part of new electronics, maybe even the smartphone you are holding right now. Plastic is ready for a new life too, as storage bins, furniture components, or even park benches. Hazardous elements, like leftover grease, paint, or circuit boards with heavy metals, are not dumped into common containers. They are sealed in special packaging and sent to facilities designed to neutralize or dispose of them safely, so they do not harm the environment. And just like that, once all the parts are sorted, your old meat grinder begins its journey into a new life. The dust settles, machines hum. On the horizon, a new device appears, maybe built from your grinder's very parts. One day, you might pull up to the park in your car with shiny wheels, sit on a plastic bench, grab your smartphone to snap a photo of a new playground and a blooming tree, and realize part of your old meat grinder lives on in everything around you. It was all worth it. Every bit of effort and time you spent recycling that old appliance paid off. And the best part, you can keep doing it. The cycle is complete. Your meat grinder did more good than some people ever will. What do an old iron and thousands of dollars have in common? That is right, copper. You know, just from one single cord, you can pull out enough copper to make brand new electronics. Every day, tens of thousands of old irons are recycled around the world, taken apart down to the very last screw. But how exactly does this happen? Why can even the sole plate be dangerous? And what is hiding inside the heating element? I am about to show you how dead irons come back to life, from being taken apart to becoming valuable raw materials. Like other electronic appliances, irons are accepted at special electronics collection points. There, they are sorted into categories: those that can be repaired, those that need to be disassembled for parts, and those sent for complete recycling. Worn out or non-working irons are sent to recycling facilities, where the disassembly process begins. When an iron arrives at the disassembly line, specialists wearing protective gloves check it over. Some parts, like the heating elements, can be hazardous due to residual electrical voltage or toxic substances. First, they remove the electrical cord. Its insulation is usually made of synthetic plastic or rubber, and inside there is copper or aluminum wire. Synthetic plastic is durable, flexible, and water-resistant, but when heated or burned, it can release toxic substances, including dioxins, which are harmful to the environment and human health. That is precisely why disposing of it requires special methods. The removed cord is not just set aside, it immediately goes onto a sorting line. First, it is chopped up in a special shredder into pieces about 1 to 2 inches long. This makes it easier to separate the metal from the insulation later on. Next comes the material separation. This is usually done using mechanical or electrostatic sorting methods. What does that mean? What kind of fancy words am I throwing at you here? Look, the copper and aluminum wires are separated and sent off to metallurgical plants for melting. The shredded plastic or rubber goes for recycling, for example, to make new cable insulation or other products. If the insulation contains harmful additives, it might be incinerated in special furnaces equipped with filters or sealed away in a landfill. Separating the copper and aluminum from the shredded electrical cords happens in several stages. So, after the cord is shredded, the pieces are sent to a granulator. This is a special grinding machine that breaks down the pieces of wire into even tinier particles, measuring about 0.04 to 0.08 of an inch across. This is how the metal and plastic get separated. Next, the mixture goes into an air separator. This uses a stream of air that lifts the lighter particles up, while the heavier ones fall down. This way, the plastic is separated out even before the main process. If there are any steel components in the wires, like a thin shielding layer or reinforcing fibers, they are removed using a magnetic conveyor belt. But the tricky part is, the little pieces of aluminum wire and copper wire get mixed together, so now they need to be separated. To do this, the metal particles are sent into a metal drum that is charged with high voltage. Copper has different electrical conductivity properties than aluminum, so under the influence of electrostatic forces, they bounce off in different directions and are collected in separate containers. After sorting, the materials are checked again, either by hand or using automated systems. Copper, which is 99% pure, is melted down at a temperature of 1,979 degrees Fahrenheit and used for new cables. Aluminum melts at 1,220 degrees Fahrenheit and is used to make parts or casings for electronics. This process allows up to 95% of the metals from the cords to be reused, reducing the need to mine new raw materials. Meanwhile, back at the iron, the housing is unscrewed. This could be a plastic or metal shell, depending on the model. A worker wearing gloves firmly secures the device on a table coated with a thin layer of metal shavings, leftovers from previously disassembled appliances. An automated screwdriver mechanism, humming almost silently, moves toward the first screw. The bit fits precisely into the screw head, makes a few quick turns, and the loosened screw flies out into a special container, clinking against the sides. The housing still holds on, as if resisting its fate. But the hands of the technician, seasoned by thousands of these operations, know how to make it give way. A slight pry with a tool under the edge of the housing, and there is a familiar click, like an old machine sighing. The plastic cracks, yields, and then splits into two parts, revealing the device's insides. If the housing is metal, it all happens with different sounds. The metal screws fall heavier. The housing slides across the table with a dull clatter. Sometimes, special cutters have to be used. Sharp blades sink into the thin metal, leaving behind jagged edges that glint under the lights. Finally, the shell is removed, and the device, just a moment ago solid and sealed, seems almost vulnerable. Its insides exposed, ready for the next stage of disassembly. Once the housing is off, the heart of the device is revealed. The circuit board and the heating element connected by a network of thin wires. They are like the veins that powered the appliance in its former life. Tweezers with pointed tips move towards the first contact point. A gentle tug, and the wire pulls away from the board with a faint snap, exposing a tiny copper core. Another tool, resembling a miniature pry bar, slips under the edge of the board. A little pressure, and the board pops out of its place, leaving behind a web of connectors and mounting points. The heating element is the next hurdle. If it is ceramic, it sits inside like a white heart, sometimes coated with a grayish film from countless heating cycles. If it is a nechrome coil, it is wound into a delicate spring, resembling a dried leaf. It is removed carefully to avoid damage, because even the smallest break can complicate further processing. And just like that, with a few more movements, the once unified mechanism falls apart into separate components. The circuit board and heating element are separated, ready for sorting and further processing or disposal. The last part holding its ground is the sole plate. It has absorbed thousands of heating and cooling cycles, signs of use, scratches, and faint traces of scorch marks. It is the sturdiest part of the device, and removing it is not so easy. To get it off, they take a tool similar to a thin pry bar and wedge it between the main body and the sole plate. A barely perceptible push, and you hear a characteristic scraping sound as the metal begins to yield. If the sole plate is aluminum, it bends under pressure, making a slight crunching sound. A ceramic one stays put until it gets a precise tap, after which it separates from the body with a muffled thud. If it is stainless steel, it puts up the most resistance. It often has to be unscrewed by hand or pried off using special levers. Finally, the sole plate is detached. It drops onto the metal table with a dull thud, leaving traces of grime on the worker's fingers. This is the last major piece, and now the appliance is completely disassembled, ready for further sorting and recycling. Every day in the United States, folks toss out 27,000 microwave ovens. That's nearly 2.5 million a year. But what happens to them once they're kaput? You'll be shocked at how wild the recycling process gets. From tearing apart transformers packed with hazardous stuff to digging out gold from circuit boards, every step is a jaw-dropper. How do factories handle hundreds of tons of metal daily? Why do magnetrons need special treatment? And what's the deal with the plastic parts? Stick around to the end to uncover the secrets of e-waste recycling. Recycling microwave ovens in the United States of America is a tricky business, involving a bunch of steps, all geared toward cutting down environmental harm and squeezing every bit of reusable material out of them. It all kicks off with properly disposing of the oven according to local rules and laws. Tons of towns have special e-waste drop-off spots where people can hand over their old appliances. Plus, big retail chains and microwave makers often run take-back programs, sometimes even tossing in discounts on new buys as a sweet deal. Once the thing lands at a recycling center, the first move is breaking it down and sorting out the main parts. This happens at specialized e-waste recycling hubs or appliance recycling plants. These places are scattered across the United States, mostly clustered in industrial zones or near big cities where electronic junk piles up fast. Some are private outfits, while others roll under city-run recycling efforts. First off, workers figure out if the oven can be reused or if it's headed for a full teardown. If the microwave's in rough shape, it goes straight to the disassembly line. They start by yanking off the outer shell, usually made of steel or aluminum. Breaking down microwave ovens can happen by hand or with machines. In smaller recycling spots, most of the work's done manually with basic tools like electric screwdrivers, pliers, hydraulic shears, and teardown stations. They unscrew the outer metal panels first, popping open access to the guts inside. Workers pull out the big pieces, like the magnetron, transformer, circuit boards, and wiring. The metal bits get squashed and shipped off to steel mills, where they're melted down for reuse. Inside every microwave is a magnetron, the thing that pumps out those microwaves. It's got ceramic insulators, copper coils, and a tiny bit of toxic stuff, like beryllium. Since beryllium dust can be nasty, magnetrons get handled with care, using protective gear and special recycling tricks. At big industrial recycling centers, they roll out automated teardown lines. A key player here is the electronic shredder. Think machines like the hammer mill or SSI dual shear, stretching 15 to 20 feet long and chewing through hundreds of microwaves an hour. After shredding, the materials hit magnetic separators, which pull steel apart from the rest. At heavy-duty plants, teardown's a multi-step gig with fancy machines. For transformers, they use hydraulic cracking presses to bust open the casing and get at the copper or aluminum windings. To snag precious metals from circuit boards, they dunk them in chemical baths or fire them up in furnaces at over 2,000 degrees Fahrenheit to melt out the good stuff. On average, big plants can rip apart 500 to 1,000 microwave ovens a day, depending on how much gear comes in and how automated they are. At smaller outfits, where it's mostly handwork, they process 50 to 200 units daily. Next, they yank out the circuit boards, loaded with resistors, capacitors, and microchips. These get handed off to companies that extract precious metals like gold, silver, and palladium. The copper wiring inside gets peeled out and recycled too. While exact numbers on precious metals from microwaves in the United States are hard to pin down, e-waste recycling overall brings a hefty haul of valuable materials back into the game. Another big piece is the high-voltage transformer, made of a metal core and copper or aluminum windings. Since it's got insulation that could be risky, recycling it takes some extra steps. The main hassle with transformers is their density and toughness, making it a chore to pull out the materials fast. Teardown starts by prying the transformer loose from the microwave's shell. This happens manually or with electric screwdrivers and teardown stations. Then it's hauled to the recycling zone. If it's by hand, workers use hydraulic shears, grinders, or metal cutting presses to slice open the outer casing. The transformer's core, usually layered steel, needs serious muscle to split, so big plants lean on industrial shredders or hydraulic presses. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. Beyond the mechanical approach, some plants use heat to break down insulation. Transformers get roasted in special furnaces at 1,000 to 2,000 degrees Fahrenheit to burn off organic junk and free up the metals. In some cases, they go with chemical leaching, soaking the transformer in acid, or alkaline baths to dissolve certain parts. Extra caution's needed with the insulation, since it might hold toxic stuff. Older models, for instance, used varnishes with polychlorinated biphenyls, nasty chemicals. So recycling those means wearing protective gear and sending the waste to special hazardous material plants. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. According to the United States Environmental Protection Agency, about 25% of e-waste, including microwave ovens, gets recycled. Every day, around 27,000 microwaves get retired across the United States, adding up to roughly 2.5 million a year. Recycling cuts down on landfill clutter, helping keep soil and water free of toxic leaks from electronic gear. Properly handling hazardous parts, like capacitors or insulation, stops harmful stuff from hitting the environment, which is a win for people's health and ecosystems. Thousands of tons of Doritos are eaten around the world every year. Imagine giant harvesters gathering tons of corn to produce 70,000 bags of your favorite snack every single day. Want to find out how ordinary corn kernels turn into the crunchy triangles we all love? Then let's take a trip to the Frito-Lay factory and uncover the secrets behind making one of the world's most popular snacks. Arch West, the head of marketing at Frito-Lay, founded Doritos in the 1960s. He discovered crispy tortillas at a nearby restaurant in San Diego, California. The idea to cut corn tortillas into triangles, fry them, and season them came to him when he had leftover tortillas that couldn't be used because they were broken or didn't meet the standards for sale. The word Dorito comes from the Spanish word dorado, meaning little pieces of gold. Doritos became the best-selling chips in the world in 1988 and remain popular to this day, with 10 different flavors available. The main ingredient in Doritos is cornmeal, which sets them apart from regular potato chips. Corn cobs are carefully harvested from the plants. The cut has to be cleaned to avoid damaging the kernels and to keep the cob intact. Up to 140 tons of corn can be harvested in a single day, ensuring the factory has everything it needs. The stalks are cut just above the ground, then the cobs are removed and tossed into a container. Once the container is full, the large pile of corn is loaded onto a truck for processing. The supplier cleans and dries the corn kernels. The process involves passing them through a vibrating sieve to remove dust, as well as any stones or sand. The moisture level of the kernels then needs to be raised to 14%, which is critical for the next stage of production, where the corn is sent to the nacho factory. Every day, 99,000 pounds of corn are delivered to the factory. The dried corn is transferred from massive silos into a pot, where it is cooked in water. This amounts to over 14.3 million pounds of finished product per year. That's a lot of corn. Frito-Lay operates one of the largest chip-making factories in the world, producing more than 100,000 bags of nachos daily. The factory is divided into 4 main zones. In the corn zone, tortilla products like Doritos are made. At the center is a 700,000 square foot distribution center. About 70,000 bags of Doritos are produced per day, which adds up to roughly 18 million bags annually. Upon arriving at the factory, the first thing you notice are the 2 corn storage silos, each holding 265,000 pounds. From this supply, the factory can produce 44,000 pounds of Doritos. To make Doritos, the corn must be cooked before being placed in the soaking tanks. First, it is boiled in large kettles with stirrers at near boiling temperatures. Then, the corn is transferred into 18 open tanks, where it is left to soak for about 12 hours. Each kettle holds around 660 pounds of corn and about 200 pounds of water. The corn is boiled for about 4 minutes at 200 degrees Fahrenheit, and then left to soak for 12 hours. After cooking, the corn is transferred into large tanks, where it soaks overnight to soften. The corn is left for 12 hours to absorb more water. The soaking process allows the corn to take in moisture and helps remove the hull, the outer shell of the kernels. A machine filters out the water, leaving only soft, hydrated corn. When the moisture content reaches 45% and the hulls are softened and loose, the corn is sent to a washing machine by a pumping system. The loose hulls are removed with a water spray. From the drum, The corn is carried on a conveyor belt to the milling machine. After being cleaned, it enters the grinder, where rotating millstones grind the corn into a dough. The kernels are literally crushed between two stones, resulting in a smooth corn paste. During the milling process, water is added to the cornmeal to create the right dough consistency. The dough is checked for 3 key factors: moisture content, temperature, and grind texture. It exits the mill through a small nozzle, forming a thin sheet. This dough sheet is placed between 2 metal rollers. A third roller is responsible for cutting the dough into individual triangular nachos. The dough sheet passes through rollers with triangle-shaped indents. First, it goes between the 2 rollers, then through a cutter that gives Doritos their signature shape, much like a cookie cutter. The sharp edges of the roller cut the dough into perfect triangular pieces. This machine can cut 6,000 chips per minute, producing over 8 million chips a day. The cut chips are placed on a conveyor belt that carries them to the next stage, the oven. Although the process is well designed, there's always some leftover dough, but it doesn't go to waste. It's sent right back to the dough vats to start the process all over again. Now it's time to cook those tortillas. The triangular chips are placed in an oven at 644 degrees Fahrenheit. However, this isn't just any oven. It has 3 temperature levels and reaches several hundred degrees. The nacho triangles spend only a few seconds in the oven to give them the right texture and prevent drying out, while sealing in moisture that creates the signature Doritos bubbles. The industrial oven seals the outer surface, locking in moisture, which causes the dough to puff up and form bubbles. This is what makes Doritos so crunchy. 16 seconds in the oven is enough to dry the dough just enough so it doesn't break when handled. The bumpy texture of Doritos is a result of the heat pulling small moisture bubbles to the surface of the dough. The tortillas are then cooled on several conveyor belts and sent to the fryer. This brief pause also allows inspectors to check that none of the tortillas burned in the oven. The triangles are fed into the fryer on a conveyor belt. The oil is heated to 360 degrees Fahrenheit, and the nachos are fried for 55 seconds. During this time, the nachos develop the perfect color and texture. The bubbles on a finished Dorito are air pockets formed during the frying process. They are then removed using a mesh conveyor belt. As they come out, the fryer is filled with leftover oil. Next, the Doritos are transferred using vibrating conveyors into a special drum, where they are mixed with the right seasonings and ingredients. At the next station, a screw conveyor feeds the nacho seasoning into the drum. Huge bags of the seasoning mix are added to the top of the machine, and a hopper containing the secret blend of cheddar cheese, Parmesan cheese, and spices is placed into the drum. Various cheeses, spices, flavor enhancers like monosodium glutamate, and preservatives are the key ingredients that extend the product's shelf life. To make the surface of the nachos stickier so the seasoning adheres, some nozzles coat the nachos with canola oil. Despite how intimidating the large drum might seem, it evenly distributes the seasoning. The delicate chips are handled in a way that prevents them from breaking apart while moving through the drum. To ensure they are fully cooled before packaging, the seasoned Doritos move along a 98-foot conveyor belt. Once the nachos exit the drum, they head to the packaging section. Through hoppers, they are directed to various packing machines. The highlight of technical choreography is the packaging device. Each machine has 14 bucket scales. The Doritos are positioned, then passed through a weighing machine where a series of scoops accurately measures the weight of each bag of Doritos. A trapdoor opens, releasing the nachos, and the machine forms a strip of aluminum and plastic into a bag once enough chips are ready for packaging. The nachos drop into the bag, which is sealed and cut using heat, as the bottom of the next bag closes. Nitrogen is pumped into the bag, which is then sealed airtight. This process prevents oxygen loss, keeping the Doritos fresh for an extended period, and creating an air cushion to prevent the chips from breaking. Each large bag of Doritos contains about 100 chips. An operator ensures that each box holds 8 bags. The plant's production and packaging output of 70,000 bags of Doritos per day adds up to more than 18 million bags per year. This is California, USA, where around 1.7 million cows on thousands of dairy farms produce more than 13 million gallons of milk every day. So, how does this massive amount turn into the sweet treat that once saved soldiers' lives and changed history? I visited one of the largest factories in the world to dive into the fascinating process of making condensed milk and to share the story with you. In 1856, American inventor Gale Borden first came up with this product. His creation solved the dilemma of preserving milk in the days before refrigerators, making it possible to store milk in cans for at least a year. During the American Civil War, it played a crucial role in supplying soldiers with milk in combat zones where dairy cows were not available. Thanks to its long shelf life and valuable nutritional properties, it became the preferred choice for feeding soldiers. The process of making condensed milk begins on dairy farms. To meet the high demand for this delicious product, factories like Nestlé's in California operate around the clock, 24 hours a day, 7 days a week. This factory processes more than 420,000 gallons of milk daily. Massive tank trucks arrive non-stop, transporting between 130,000 and 185,000 gallons of milk each day from nearby farms. Most of the incoming milk was collected just 6 hours earlier, so it's incredibly fresh. However, before the milk is accepted, it undergoes lab testing. The fat and salt content must meet factory standards, and the milk must be free of antibiotics to avoid allergic reactions in some people. But where do the farmers get such milk? Most of the milk in the US comes from roughly 60,000 dairy farms, where over 9 million cows are raised specifically for milk production. Over the past century, the milking machine has become an essential tool. The part of the machine that attaches to the cow's teat is called a cup, and it works similarly to a hand, applying pressure to the udder to extract milk. A farmer can manually milk about 6 cows per hour, but with a specialized device, that number can jump to 100 cows per hour. The ingenuity of this innovative device has optimized milk production, but the way a farmer cares for their cows also impacts the quality of the milk. The more care given to the animals, the longer their lifespan and the more milk they produce. On this massive dairy farm, 8,000 cows graze. It's one of many farms that use technology to improve cow living conditions and boost productivity. In cow carousels, known as milking parlors, up to 80 cows can be milked at once, twice a day. Dairy cows are creatures of habit, and they enjoy sticking to a routine, which makes the milking process smoother. These advanced milking parlors outperform traditional machines, increasing the milk flow rate by 30%. Before attaching the milking cups, workers disinfect the cow's udders with an iodine solution. This process mimics the sucking motion of a calf to ensure organic milk production. The entire procedure takes about 7 minutes, and after milking, the cups automatically detach. These animals spend around 8 hours a day eating. Consuming 100 pounds of feed and 80 gallons of water, a cow can produce up to 10 gallons of milk a day, 7 days a week. Thanks to technological advancements and more nutrient-rich feeds, today's cows are 3 times more productive than they were 50 years ago. A dairy cow starts producing milk at around 2 years old, once she gives birth to her first calf. Typically, the calf is separated from its mother within an hour of birth to prevent harmful bacteria from reaching the mother's udder. From then on, the calf is bottle-fed with its mother's milk, while the cow begins her career as a milk producer. For 305 consecutive days, the cow is milked twice a day, after which she gets a well-deserved 60-day break to give birth to another calf. Once the cow delivers, the milking process begins all over again. The liquid produced by cows is a nutrient-rich substance that consists of 87% water. This process begins when food is digested in the cow's stomach and transformed into nutrients, which are absorbed into the bloodstream. These nutrients travel to the mammary glands, where they are converted into the valuable liquid we know as milk. Milk is collected from the udder at a temperature of 90 degrees Fahrenheit and transported via pumps into storage tanks, which are then cooled. In these tanks, the milk is stored at a safe temperature of 36 to 37 degrees Fahrenheit. However, at this stage, the milk is still in its natural state and may contain harmful microorganisms. That's why it is loaded into a 5,300-gallon tanker truck and taken to a dairy processing plant. After the milk has passed all stages of quality control, it is sent to a centrifuge separator to speed up the separation process. In the top section, cone-shaped discs spin at an impressive speed of 7,000 revolutions per minute, processing over 5,800 gallons per hour. Under the force of centrifugal action, the heavier skim milk moves outward, while the lighter cream moves toward the center. As a result, we get cream with a fat content of around 20% and skim milk with a fat content of less than 1%. The skim milk serves as the starting point for making condensed milk. Next, the milk undergoes the pasteurization process to destroy any bacteria present. To begin this procedure, the milk is first cooled to a temperature of around 37 degrees Fahrenheit, then passed through a heat exchanger that raises its temperature to 162 degrees Fahrenheit. After heating, the milk is transferred to a chamber where it is held for 15.5 seconds, achieving the required level of pasteurization. The milk is then cooled back down to 37 degrees Fahrenheit. In less than 40 seconds, complete pasteurization reduces the bacteria count in the product by 99%. Before the introduction of pasteurization technology, most consumed milk was in its natural state, leading to quick spoilage and exposing people to the risk of infection from potentially dangerous microorganisms. In 1862, the famous French scientist Louis Pasteur proposed an innovative solution originally aimed at preventing wine from spoiling, which was later applied to milk. After milk is pasteurized, a large amount of sugar is added to it. The sugar not only gives the milk a sweet taste, but also acts as a preservative, helping to extend its shelf life. The mixture of milk and sugar is reheated so that the sugar fully dissolves and becomes uniform. The heat not only helps dissolve the sugar, but also prevents the formation of crystals that could affect the smooth texture of condensed milk. After this, the milk enters an evaporator, an enormous device designed to remove water from the milk. At this stage, the milk becomes thicker as the water content is reduced by about 60%. Using heat and pressure, the evaporator manages to evaporate the water from the milk without altering its properties, allowing the concentration of solids like proteins, sugars, and fats. This process gives condensed milk its thick texture and delightful sweet flavor. The evaporator consists of a series of vertical structures called calandrias. Inside each calandria is a set of stainless steel tubes through which the milk circulates. A steam chamber surrounds these tubes. The milk enters each calandria from the top and flows down through tiny channels. As it moves downward, the steam enveloping the tubes heats the milk, causing the water within it to evaporate. Once the milk reaches the desired thickness, it is removed from the evaporator. Next, the milk undergoes an additional process called homogenization, where the fat is broken down into small uniform particles to improve its consistency and stability. Before the condensed milk is packaged, the containers must be sterilized to eliminate any microorganisms that could affect the product's quality. Once the condensed milk is processed and has reached the perfect consistency, it is transferred to a packaging machine. These machines precisely measure the required amount of product into each container, ensuring consistency and reducing waste. After filling, the containers are sealed tightly to prevent any contaminants from entering. To ensure the product's safety, the filled and sealed containers undergo an additional sterilization process. The cans are placed in autoclaves, where they are exposed to steam under high pressure to destroy any remaining microorganisms. This procedure ensures that the condensed milk inside the container is completely safe to consume and has a long shelf life. In addition to meeting domestic demand, condensed milk is widely exported around the world. Thanks to its long shelf life and high nutritional value, it is a popular product in countries with limited access to fresh milk. Condensed milk-producing countries like the United States and several European nations actively supply this product to markets in Asia, Africa, and Latin America. The export of condensed milk helps strengthen international trade relationships and ensures that people in various regions have access to quality dairy nutrition. Have you ever wondered how Red Bull, that famous energy drink, makes us feel like we have wings? How a tiny can hold so much energy? Today we're uncovering the secrets behind the creation of this iconic drink. Take a fascinating journey through the Red Bull factory with us and discover the secret ingredients that are added to the energy drink. The process of creating Red Bull begins with a careful selection of ingredients. The key elements are caffeine, taurine, sucrose, B vitamins, and vital fluid. Each ingredient undergoes rigorous quality testing to meet the company's high standards. It is commonly believed that taurine is extracted from bull semen, but Red Bull uses artificial taurine created in a laboratory, ensuring that the drink is perfectly compatible with a vegetarian diet. Taurine promotes muscle activity, reduces stress, controls blood glucose levels, and boosts cardiovascular health. The caffeine in Red Bull promotes attention, concentration, and physical performance. According to the European Food Safety Authority, the ingredients in Red Bull are considered harmless when consumed in moderation. However, as with any product, the key is to strike the right balance. Each ingredient is prepared individually. The water undergoes various stages of purification and sieving to achieve the required degree of purity. Sugar is melted in water to form a tasty syrup, which is then pasteurized. Vitamins and taurine are diluted in separate containers before further blending. Once prepared, all ingredients are mixed in large containers. Inside these containers, the ingredients are carefully combined according to the given formula. At this stage, carbon dioxide is added to give the drink its characteristic fizziness. Once mixed, the drink undergoes several filtration steps to remove any remaining impurities and ensure the product is completely pure. The liquid then undergoes a pasteurization process to kill bacteria and extend its shelf life. At the same time, the beverage is poured into aluminum containers. Aluminum foil is cut and shaped into the thin, recognizable form of cans. An internal coating is applied to prevent the drink from reacting with the metal, thus preserving the essence and taste of the product. Next, the mixture moves to automatic filling machines, which fill thousands of cans per minute. Each can is sealed airtight to maintain freshness and undergoes pasteurization to remove any contaminants that may be present. The exterior of Red Bull cans is not only visually appealing, but also functional and fully recyclable. Before filling, the cans are cleaned and sterilized, and the filling process is automated and carried out at high speed. Did you know that recycling a single aluminum can save enough energy to power a television for 3 hours? Red Bull is passionately committed to developing energy-efficient production and reducing carbon dioxide emissions. The company continues to explore creative ideas, such as producing lighter cans and implementing sustainable energy solutions. Once filled, the cans go through a labeling station, where they are stamped with the manufacturing date and expiration date. They are then grouped into sets and packed in cardboard for easier transport. At every stage of production, strict quality control is enforced. Experts test samples of the beverage to ensure they meet standards, and they perform regular equipment checks to prevent potential breakdowns. The packaged cans are stored in controlled conditions until they are shipped. From there, all the products go to distributors and retailers, and eventually reach the customers. Red Bull Energy Drink, produced in Austria, is distributed in over 170 countries worldwide. About 7.5 billion cans are produced annually, which equals 21 million cans a day. The primary markets include the United States, Germany, the United Kingdom, Japan, and Brazil. Transportation is carried out by road, rail, sea, and air, covering vast distances. Every year, more than 100,000 containers filled with Red Bull make their way across the seas to eager consumers. Red Bull spends significant amounts on marketing strategies, such as supporting Formula One and extreme sports, which helps the company maintain its dominant position in the energy drink sector and attract countless new consumers each year. The story of Red Bull began on the bustling streets of Bangkok, Thailand in 1982. During one of his business trips, Austrian entrepreneur Dietrich Mateschitz came across a refreshing local drink known as Krating Dang. Impressed by its ability to combat fatigue and jet lag, Mateschitz saw enormous untapped potential for the drink in Western markets. In collaboration with the Thai inventor of the beverage, Chaleo Yuvidya, they rebranded it and introduced Red Bull in Austria in 1987. Mateschitz and Yuvidya didn't just change the name, they adapted the flavor to suit Western consumers and developed an original marketing strategy, focusing on extreme sports, excitement, and youth culture. The iconic phrase, "Red Bull gives you wings," became a symbol of pushing limits and chasing thrilling experiences. Red Bull takes pride in its commitment to environmental sustainability. The company launched the Red Bull Amifico project, which supports social entrepreneurship initiatives around the world. Red Bull places a strong emphasis on conserving energy and reducing its environmental impact by focusing on renewable energy sources and efficient transportation systems. Red Bull is not just a beverage, but also a source of inspiration for innovation and creativity. The company actively invests in technological projects and initiatives, supporting young talent through the Red Bull Basement Program. This program is aimed at encouraging students and entrepreneurs who use technology to solve global challenges and improve society. Red Bull's unique connection to the world of extreme sports has delivered many unforgettable moments. In 2012, with the company's support, Austrian skydiver Felix Baumgartner made a historic jump from the stratosphere, leaping from a height of 24 miles and breaking the sound barrier, along with setting several world records. This daring project, known as Red Bull Stratos, showcased the company's commitment to pushing the boundaries of what is possible. Looking ahead, Red Bull continues to expand its horizons by introducing new products and technologies. The company is exploring opportunities in the fields of alternative energy and sustainable development, aiming to reduce its environmental footprint. Additionally, Red Bull plans to increase its support for music and cultural events, creating platforms for artists and creative individuals around the world. Each year, more than 93 million short tons of delicious oranges are harvested worldwide. Over 60% of that amount is used to produce bottled orange juice. But how is this process carried out in industrial plants? To find out, let's visit a factory in the United States that specializes in producing more than 530,000 gallons of orange juice per day. An orange plantation consists of evergreen trees with vertical trunks and compact rounded canopies. Their sturdy trunks are made of strong wood and covered by a thin bark, which can range in color from green to gray-brown, depending on the layout of the plantation. These trees can grow to heights between 20 and 33 feet. To successfully grow oranges, ideal conditions are required. The perfect elevation for the trees is between 1,600 and 330 feet above sea level, and the optimal temperature is 75 degrees Fahrenheit. It's essential that the soil is slightly alkaline, with good drainage capacity. Sunlight is also crucial, especially during the flowering and fruiting periods. Oranges can be propagated in two ways, sexually through seeds or asexually through grafting. The fruit-bearing timeline depends on the propagation method. If grown from seeds, it can take up to 7 years for the trees to start producing oranges. In contrast, using grafting can reduce this time to about 3 years. Once the tree has flowered, the fruit typically matures over a period of 6 to 14 months. For the best quality and flavor, it is recommended to harvest oranges 2 to 3 months before they fully ripen. Oranges undergo multiple checks to determine their ripeness. The ratio of sugar to water is tested, and when the sugar content reaches at least 10%, they are ready for harvest. Citrus fruits are picked at their peak sweetness and juiciness because they do not continue to ripen after being harvested. For the production of freshly squeezed juice, 2 main varieties of oranges are typically used: Valencia and Hamlin. These oranges are hand-picked while they are still slightly underripe. Harvesters carefully inspect each orange, discarding any that have cuts or holes to prevent possible damage to the inside. However, on large plantations where many oranges ripen simultaneously, the harvest must be completed quickly. To speed up the process, a device known as a tree shaker is used. This machine grips the tree branches and shakes them vigorously to release the oranges. Capable of harvesting up to 4,400 pounds of oranges per minute, it greatly accelerates the harvest in large citrus groves. Although mechanical harvesters, which can cost around $500,000, are able to collect between 88,000 and 110,000 short tons of oranges per year, many farms still rely on manual labor, requiring hundreds of workers to get the job done. Workers carefully place the juicy oranges into large canvas bags and carry them to containers. This manual approach allows for more careful selection and reduces the impact on the fruit. The juicy oranges are sent to the juice production plant and first pass through a cleaning station, which works much like a car wash at a gas station. An environmentally friendly soap solution is applied to the fruit, and rotating nylon brushes scrub them as they move along a long conveyor belt. Afterward, the soap is rinsed off with cold water, and the oranges are dried using blasts of air from fans. Once they exit the drying machine, the fruit is carefully inspected by a specialist to ensure that no bad oranges were missed. At the sorting stage, some modern production lines are equipped with more advanced scanners that provide additional assistance in identifying any issues. In the final step, the oranges pass through a series of gentle brushes that remove any remaining dust and dirt. It's time to move on to the juicing process, the most crucial step in producing delicious orange juice. After thorough cleaning, the oranges are fed into a machine known as an extractor. This extractor was specifically designed to maximize both the efficiency and quality of the juice. It consists of a pair of round metal ridges that forcefully pierce the orange peel, remove it, and extract the juice. During this process, not only is the essential liquid extracted, but also the seeds and the bitter white layer, called the albedo, which separates the soft pulp from the tough outer skin. The goal is to produce juice that is as pure and flavorful as possible, free of any components that might negatively affect its taste or texture. After the juice is extracted, the nectar is collected in a reservoir. Here it passes through a filtration system that allows the pulp level to be adjusted based on customer preference. Fine mesh filters produce a smooth, clear juice, while more open filters let through small pieces of pulp, resulting in a thicker, more fibrous juice. The orange juice then undergoes pasteurization to ensure safety, followed by rapid cooling before being bottled or stored in massive 10,500-gallon containers at 39 degrees Fahrenheit to preserve its properties. It takes approximately 13 to 15 oranges to produce 1 quart of juice. This process ensures that every tiny drop of nectar is packed with exquisite, bold flavor, rich in the fruit's valuable nutrients. Before packaging, a thorough quality inspection is conducted to ensure the final product meets the highest standards. Various aspects of the juice, such as sweetness, acidity, pulp content, citrus essence, texture, and most importantly, taste, are checked. These checks guarantee that every batch of orange juice maintains a consistent and refined flavor. After the juice passes quality control, it moves to the bottling line. Cardboard cartons and plastic containers travel along a complex automated production line, where they are filled and sealed tightly to preserve freshness. This procedure is carefully designed to minimize exposure to oxygen and prevent oxidation, ensuring the juice retains its delicious flavor and valuable nutrients. Once bottled, the freshly squeezed orange juice is quickly cooled to prevent any potential spoilage, and then transported in refrigerated trucks to supermarkets across the country. Rapid cooling is essential to maintaining the product's freshness until it reaches consumers. The refrigerated trucks keep the juice at the ideal temperature throughout the entire journey, preventing any changes in taste or quality. From the moment oranges are harvested to when the juice appears on supermarket shelves, every step of the process is carefully planned to ensure that customers can enjoy a product of the highest quality. Thanks to innovative processing methods and strict quality standards, the delicious flavor and nutritional benefits of orange juice are guaranteed to stay fresh and natural. The numerous health benefits of orange juice are truly endless. Packed with vitamins A and C, it boosts the body's immune defenses, helping to prevent illness. It also aids in preventing anemia, as vitamin C enhances the absorption of iron, which is essential for producing hemoglobin and transporting oxygen through the blood. In addition, orange juice helps slow down premature aging due to its antioxidants, such as beta-carotene, lutein, and zeaxanthin, which protect the skin and stimulate collagen production, reducing wrinkles and maintaining skin elasticity. It also helps prevent high blood pressure thanks to its potassium content, which relaxes blood vessels and helps regulate sodium levels in the bloodstream. Not only does orange juice combat inflammation and reduce oxidative stress due to its anti-inflammatory properties, but it also supports the prevention of chronic diseases. Today, orange cultivation is one of the most prosperous industries worldwide. The leading producer of this fruit is Brazil, followed by India, China, Mexico, and the United States. Oranges, which belong to the Rutaceae family and the citrus genus, stand out among their relatives, a group that includes around 16 species known for their delicious, vitamin C-rich fruits. Successful cultivation of oranges requires a variety of techniques and careful maintenance, as environmental factors can significantly affect the plants and their fruits. This includes aspects such as morphology, size, color, texture, and the balance of acidity and sugar. The origin of the word orange traces back to the Arabic word naran. Sweet oranges are believed to have originated in southeastern China, and it is likely that the Romans introduced them to Europe. However, it wasn't until the early 15th century, after Marco Polo's travels to China, that Genoese merchants brought the cultivation of sweet oranges to Europe. Later, in the 16th century, the Spanish brought oranges to the Americas, starting in the United States and then spreading them to South America, South Africa, and parts of Australia. There is no doubt that orange juice offers many health benefits. However, it should be consumed in moderation, as excessive intake can raise blood sugar levels due to its high concentration of fructose. Typically, a single glass of juice contains the equivalent of 3 to 4 oranges, so it is best enjoyed as part of a balanced diet. As a result, a vast quantity of orange juice is produced daily. Did you know that over 20 million tons of peas are grown worldwide each year? This humble vegetable is not only incredibly beneficial for our health, but it also plays a key role in agriculture by improving soil and supporting ecosystems. Today, we are embarking on an exciting journey to uncover all the secrets of peas from the field to your table. You won't want to miss it. Peas are not only delicious, but also highly nutritious. Thanks to their unique ability to fix nitrogen from the atmosphere, peas enrich the soil, making it more fertile for future crops. To grow a good harvest, peas require specific conditions. Plenty of sunlight, moderate rainfall, and well-drained soil, all of these are crucial for their growth. When summer arrives, it's harvest time. The process can be labor-intensive and may either be fully automated or require manual labor, especially when it comes to varieties of peas intended for fresh consumption. Depending on the size of the farmland and local traditions, different types of equipment are used to prepare the soil for planting peas. The planting process itself takes place in several stages. For peas to sprout and bloom, they need sufficient moisture, which is why seeders scatter the seeds across prepared beds. Irrigation methods depend on the type of soil, weather conditions, and water availability. Harvesting peas can be done by hand or through mechanization. On larger farms, combine harvesters are often used to speed up the process significantly. Specialized harvesting machines are equipped with pickup drums that gather the plants from the field and transport them to a threshing chamber. Inside this chamber, a rotating beater separates the peas from the plants. These mechanized harvesting systems can not only collect the peas but also clean them of leaves and stems right there in the field. After harvest, the peas are either sent directly for processing or go through additional cleaning and sorting. At the processing plant, the peas are placed into large receiving pits, where they undergo preliminary cleaning. From there, they are sent to a sorting line, where vibrating screens separate out any underdeveloped or damaged peas. Next, the peas are transferred to sizing machines, which sort them by size for further processing. The selected peas then move on to the washing stage, which involves several steps. An initial rinse to remove larger debris, followed by a thorough wash in tanks filled with water that is constantly filtered and refreshed to maintain cleanliness. After washing, the peas go through a blanching process, where they are briefly immersed in hot water. This step helps preserve their bright green color, retain nutrients, and improve texture. Blanching also eliminates any potential microorganisms. Afterward, the peas are rapidly cooled in cold water to halt the cooking process and maintain their freshness. Sorting is crucial to ensure only the best peas are selected. The washing process occurs on conveyor systems. First, the peas are rinsed to remove dirt, then they are submerged in specialized tanks for a more thorough cleaning. The water used for washing is often recycled and reused in the process. A crucial step for frozen peas is blanching. This process helps preserve their color, flavor, and nutritional value, while also killing bacteria and enzymes that could cause spoilage. After blanching, the peas are transferred to freezing chambers, where modern equipment rapidly lowers their temperature. This quick freezing prevents the formation of large ice crystals, helping to maintain the product's texture. Next, the peas are moved onto a conveyor belt for preservation. At this stage, they are placed into sterilized glass jars or metal cans. The peas are then covered with a hot solution made of water, salt, and sugar, which helps preserve their taste and texture over an extended period. After that, the jars or cans are sealed tightly and sent for sterilization, where they are exposed to high temperatures to eliminate any remaining microorganisms. This process ensures a long shelf life, without compromising the product's quality. Sterilization is one of the most crucial steps in the canning process. First, the jars containing the peas are heated to about 250 degrees Fahrenheit, which destroys harmful microorganisms and enzymes that could lead to spoilage. The sterilization process can last anywhere from 20 to 45 minutes, depending on the size of the jar and the density of the packing. Once sterilization is complete, the jars are quickly cooled to room temperature to prevent the glass from cracking due to thermal shock. This stage is essential for maintaining the integrity of the packaging and ensuring the product's quality. After sterilization, the peas go through a cooling phase to halt the heating process and avoid packaging ruptures caused by sudden temperature changes. Next, the canned goods move to the labeling line, where each can is marked with product information, expiration dates, and barcodes. To ensure transparency and ease of use, each can must include detailed information such as the production date, expiration date, and storage recommendations. This helps consumers feel confident about the quality and freshness of the product. After labeling, the cans are packed into cardboard boxes for transportation. At this stage, automated systems are used to place the cans in boxes with minimal manual handling, which speeds up the process and helps prevent damage. Once packaged, the cans are sent to a temporary storage warehouse before being distributed to retail locations. One of the final stages is quality control. Every step of the production process is closely monitored to ensure compliance with sanitary and technological standards. Specialized on-site laboratories regularly conduct tests to check the can's seal integrity, the presence of foreign particles, and organoleptic properties such as the taste, color, and smell of the peas. Only after passing all inspections is the product approved for shipment to the consumer. Smaller packages of peas are placed into cardboard boxes for further transportation. Automated systems and robotic arms tightly wrap each package in protective film and prepare it for shipment. Modern technology allows this entire process to be quick and efficient while maintaining high product quality. Special conveyor lines equipped with robotic manipulators carefully wrap each container in protective film, helping to prevent damage during transport and storage. Frozen and canned peas are shipped to supermarkets, stores, and markets. They are also used in the food industry to create ready-made meals. Logistics play a crucial role in maintaining the freshness of the peas. Frozen peas are transported in refrigerated trucks, while canned peas are shipped under conditions that prevent spoilage. For frozen peas, special refrigerated containers are used to maintain a constant temperature throughout the entire transportation process, which helps prevent spoilage and preserves their nutritional value. Canned peas are also transported with temperature control in mind to prevent packaging ruptures or the growth of microorganisms. Here are some interesting facts about peas. First, peas are one of the richest sources of plant-based protein among vegetables, making them an excellent choice for those who don't eat meat. 1 cup of fresh peas contains about 1/3 of an ounce of protein, which helps maintain muscle and overall health. Second fact, peas are high in fiber, which is essential for healthy digestion. Fiber promotes regular bowel movements and prevents constipation. Additionally, it supports the growth of beneficial bacteria in the gut, improving the microbiome and strengthening the immune system. Third fact, NASA has included peas in its list of plants suitable for growing in space. Their high nutritional value, ability to improve air quality through photosynthesis, and ease of cultivation make peas an ideal candidate for space missions, such as expeditions to Mars. Have you ever wondered how simple ingredients come together to create 100 tons of the legendary Nutella? We start with 20 tons of hazelnuts from Turkey, 15 tons of sugar, and 10 tons of cocoa from Ghana, transforming them into a flavor loved by millions. From the chocolate shortages during the war to millions of jars on store shelves today, are you ready to discover how the magic happens at each step? Let's dive in. Nutella was created in Italy during World War II when chocolate was in short supply. Confectioner Pietro Ferrero mixed hazelnuts with chocolate to create a more affordable product. Originally, his recipe was called pasta gianduja, but it was eventually transformed into Nutella, which was released in 1964. Today, this chocolate hazelnut delight is available to everyone, and I'm here to walk you through the entire process, from cocoa beans in Ghana to the finished product on store shelves. Let's start with an analysis of the production plans. Here are some numbers for you. If 100 tons of Nutella are planned for production, we need to calculate the required amount of ingredients. That means around 20 tons of hazelnuts, 15 tons of sugar, 10 tons of cocoa powder, 8 tons of palm oil, 5 tons of powdered milk, and 440 pounds of vanilla. The ordering process with our trusted suppliers begins, usually from Turkey, Africa, Malaysia, and our local farms. The purchase order is based on analytical forecasts, aiming to optimize the production process and maintain top-quality raw materials. For example, 20 tons of hazelnuts are ordered 2 months before production to ensure they are fresh. Next comes the logistics. Every detail must be carefully planned since the raw materials are sourced from different corners of the world. Hazelnuts are shipped from Turkey, cocoa powder comes from Ghana, and palm oil makes its way to our warehouses by sea from Malaysia, which means transportation can take about 4 to 6 weeks. Once the goods arrive, the raw materials are stored in dry, dark facilities with strict temperature controls kept between 59 and 68 degrees Fahrenheit to prevent spoilage and oxidation. Detailed record keeping of each batch is also essential, ensuring that we can trace their origins and meet food safety standards. This step is crucial for maintaining the high quality of the final product and adhering to environmental and ethical standards. Even though the hazelnuts are shipped in specialized containers to prevent damage, they undergo a thorough quality check before processing, just like the other ingredients. This involves using contactless sensors that measure moisture levels and temperature upon receipt. The moisture content must not exceed 8%. Additionally, a visual inspection is carried out using high-resolution cameras that detect defective nuts and any foreign particles. If defects are detected, the system automatically separates them. The hazelnuts are then cleaned in automated cleaning machines, with each batch handling 1 ton of hazelnuts at a time. The process takes around 30 minutes, during which air streams remove the skins and other light particles. Quality control is maintained through sensors that monitor airflow speed and adjust the intensity of the cleaning process in real time. The cleaned hazelnuts are then automatically transferred to roasting ovens. We set the temperature between 320 and 360 degrees Fahrenheit and wait for about 15 to 20 minutes. The ovens are equipped with automated thermal sensors that monitor temperature and humidity levels. If the humidity exceeds 1%, the system automatically adjusts the roasting parameters. After roasting, the hazelnuts are moved into cooling chambers, which ensure rapid cooling to room temperature, between 68 and 77 degrees Fahrenheit. This cooling process takes approximately 30 minutes. The chambers are also equipped with sensors to maintain consistent temperatures for even cooling. Next, the hazelnuts go into automated grinding machines with a capacity of up to 2 tons at a time. The grinding process takes about 10 to 15 minutes. These machines are equipped with control systems that ensure the desired paste consistency is achieved. The key objective is to reach a 50% oil content, which is essential for achieving a smooth texture. Do you smell that? I call it the scent of magic, when a few simple ingredients transform into a flavor everyone knows. Now, we're moving on to the mixing process, so let's take a closer look at how it all happens. In large mixers with a capacity of up to 30 tons, all the ingredients are loaded in. These mixers come equipped with automatic speed controllers, allowing the blade rotation speed to be adjusted based on the consistency of the mixture. We set the speed to 60 revolutions per minute and wait about 20 to 30 minutes for the process to finish. During mixing, it's crucial to monitor the temperature, as it affects the final texture of the product. The mixers are equipped with temperature sensors that automatically adjust cooling if the temperature exceeds 86 degrees Fahrenheit. Workers receive real-time temperature data, allowing for quick adjustments whenever needed. An essential process we'll discuss now is emulsification. Emulsifiers in Nutella play a key role in ensuring a smooth texture, preserving flavor, and extending the product's shelf life. For emulsification, an automated system is used for precise dosing of emulsifiers, which typically make up about 1 to 2% of the total mixture. A common choice is soy lecithin. The system ensures accuracy up to 0.1%, which is critical for the stability of the final product. The prepared mixture is then loaded into automated emulsifiers with a capacity of up to 30 tons. The emulsifier is equipped with paddle stirrers that can operate at speeds of up to 1,000 revolutions per minute, enabling rapid and efficient mixing. It's crucial to monitor the temperature of the mixture, which should not exceed 105 degrees Fahrenheit, to prevent oil breakdown and preserve flavor. To maintain this, the emulsifier is equipped with thermostats. If the temperature starts to rise, the system automatically activates cooling elements, keeping the conditions optimal. During emulsification, workers monitor the viscosity of the mixture using automated sensors. The ideal viscosity for Nutella is about 20 to 30 Pascal seconds. If the viscosity is too high or too low, the system automatically adjusts the mixing speed or adds oil to achieve the desired consistency. After the emulsification process is complete, about 30 tons of finished mixture is produced, with a temperature of around 105 degrees Fahrenheit. This temperature helps maintain the uniformity and texture of the emulsion. The finished mixture is automatically pumped into cooling tanks. The system has a capacity of around 265 gallons per minute, allowing for rapid processing of large volumes. The cooling tanks are equipped with automated cooling systems that can bring the temperature down to 68 degrees Fahrenheit within 30 to 40 minutes. Temperature is monitored in real time, using sensors to maintain stability throughout the entire process. During the cooling stage, the moisture content of the emulsion is also carefully monitored. The ideal moisture level should not exceed 5%. If the humidity is higher than the standard, the system automatically activates dehydrators to remove excess moisture. This step is crucial for ensuring a longer shelf life for the product. The finished Nutella is automatically pumped into filling machines using pumps with a capacity of up to 265 gallons per minute. The filling machines automatically portion the Nutella into jars with a volume of 14 ounces. Each jar weighs about 1 pound, including the packaging. The system ensures accurate filling with a tolerance of up to 1%, achieved through automated scales that weigh each jar during the filling process. After filling, the jars pass through an automated capping machine. It uses airtight lids to ensure long-term freshness, and the machine can cap up to 600 jars per hour, enabling the efficient processing of large volumes. Next, the jars are labeled using an automated labeling machine, which can label up to 500 jars per minute. Before starting the process, it's essential to check that the label hopper is stocked with enough labels. Each label includes information about the product, ingredients, expiration date, and barcode. Labels are applied with an accuracy of 0.02 inches, thanks to sensors that monitor the position of the jars on the conveyor belt. The system automatically checks for proper label placement and detects any defects, such as misalignment or missing labels. If the system identifies an issue, it automatically halts the machine, preventing errors in production. After labeling, the jars are automatically transferred to the packing machine. Here, they are arranged into cardboard boxes, with 12 jars per box. The packing process operates at a speed of up to 300 boxes per hour. The boxes are formed automatically without the use of glue, utilizing specialized mechanisms that ensure both speed and reliability. During packing, the system monitors the proper arrangement of jars within each box. If a box is missing jars, or if they are incorrectly placed, the system triggers an error alert. Each box is equipped with internal dividers to prevent damage to the jars during transportation. The finished boxes are then automatically fed onto a conveyor where they are stacked onto pallets, typically with about 100 boxes per pallet. Each pallet is labeled with information about its contents, making subsequent storage and transportation easier to manage. After the packing process is complete, the quantity of finished Nutella pallets is checked, usually around 200 pallets per day, with each pallet holding 100 boxes containing jars of Nutella, each with a volume of 14 ounces. An automated warehouse management system generates routes for forklifts, which transport the pallets throughout the warehouse. In the loading zone, specialized hydraulic lifts come into play, automatically raising pallets to the height of the truck's cargo area. Typically, a single truck can hold up to 30 pallets. Each truck is provided with automatically generated labels that include information about the contents, production date, expiration date, and final destination. The trucks then head out to distribution centers located up to 500 miles from the plant. The transportation status is monitored through a GPS system, allowing real-time tracking of each vehicle's location. When a truck arrives at the distribution center, the pallets are scanned again to confirm receipt, and they're then prepped for their next journey to supermarkets and into the hands of eager customers. When someone says the word hamburger, I immediately think of McDonald's. I think of that distinct taste, the speed with which the food ends up in my hands, and even the unmistakable smell in the parking lot. I've always been curious about how exactly the whole process works, haven't you? Well, in that case, it's worth starting not with the self-service kiosk or the drive-thru, but from the very beginning with the ingredients. McDonald's works with trusted meat suppliers who meet strict quality standards. Every year, the chain purchases around 100 million hamburger patties, so it's essential to find reliable factories that provide high-quality products. Priority is given to suppliers who use sustainable practices, and the company supports projects that promote animal welfare and responsible farming. The main types of meat include beef, chicken, and sometimes fish. For hamburgers, beef is used. At the factories, the beef is ground into meat for the patties and then vacuum sealed to preserve freshness and prevent contamination. Each new batch of ground beef is tested for freshness and quality, which includes checks for bacteria and other harmful organisms that could impact food safety. The meat is transported and stored at optimal temperatures between 32 and 39 degrees Fahrenheit, monitored by special sensors in warehouses and the trucks used for delivery. The hamburger buns are supplied by certified manufacturers specializing in baking bread products. McDonald's has several reliable suppliers across the country, ensuring consistent quality and freshness. The main factories are spread throughout the United States and may include companies like Bimbo Bakeries USA, Arista, and Flowers Foods. These companies use modern baking and processing technologies to guarantee the quality and freshness of the buns. In some cases, the buns are frozen to maintain freshness during transportation. To ensure product quality, McDonald's regularly conducts audits of manufacturing and storage standards, including sensory tests, evaluating taste and smell. Vegetables for hamburgers, such as lettuce, tomatoes, onions, and pickles, are supplied by local farmers and specialized agricultural companies. Each year, McDonald's sources approximately 3,300,000 pounds of lettuce, 3 million tomatoes, and 2,700,000 pounds of onions. The company partners with suppliers who adhere to quality standards and sustainable farming practices. Suppliers grow vegetables under optimal conditions, often using advanced cultivation techniques. For example, tomatoes may be grown in greenhouses to ensure consistent quality. Vegetables are typically delivered fresh, though they may also be pre-processed, sliced, peeled for convenience. This helps reduce the average order preparation time, contributing to McDonald's high level of service. For their hamburgers, McDonald's typically uses ketchup, mayonnaise, mustard, Thousand Island dressing, and sometimes BBQ sauce. These sauces are supplied by major manufacturers, including Heinz, a well-known ketchup producer, Hellmann's, the mayonnaise supplier, and McCormick, which provides other spices and sauces. These trusted factories maintain strict quality control standards and incorporate sustainable practices into their production processes. Oh, can you already taste that perfect combination of ketchup and a beautifully grilled patty? This taste takes me back to when I played baseball in middle school. I loved being a pitcher, but after an hour of practice, I didn't even want to hold the ball anymore. All I could think about was protein and carbs. It became a sort of ritual. Wait until the pitching drills were over, then head to McDonald's with my friends. Fries, cheese sauce, soda, and oh yeah, the burger. We went there so often that the staff memorized our orders. Oh, but what was I saying? Let's get back on track. We've just reached the ingredient stage. Right now, we can observe a clear and structured process for receiving products at the restaurant. Before the acceptance begins, warehouse staff review the delivery documents to confirm that the items ordered match what was delivered. This includes details like the quantity, types of products, and expiration dates. Each product has a unique barcode that is scanned using automated systems, which updates inventory in the management system automatically. This greatly simplifies the entire process. After the receipt of goods, the next step is a freshness check. For example, vegetables and meat are inspected for damage or signs of spoilage, and they undergo routine tests for bacteria and other harmful organisms. Additionally, all products that require cold storage, such as meat and dairy products, must have their temperatures checked. Digital thermometers are used for this, and the data is automatically logged into the system. Ingredients are then placed in designated areas: refrigerators for meat and dairy, freezers for frozen items, and dry storage rooms for vegetables and dry goods. Inventory levels are monitored in real time through an automated tracking system that notifies staff when stock drops to critical levels. This also helps identify trends and optimize purchasing processes. Each batch of products has a unique identifier, allowing the restaurant to track its journey from the supplier to the restaurant. Every item is labeled with its expiration date, which is automatically recorded in the system, helping to prevent the use of expired products. When you step into the kitchen at McDonald's, the first thing you notice is the organized environment with clearly defined work zones. Right now, we're focusing on the area where the magic of preparing those iconic burger patties happens. The beef patties are formed automatically using special machines called forming press machines. Each patty is standardized to about 3 ounces, ensuring the perfect balance of texture and flavor in every burger. Once formed, the patties are automatically placed onto the grill. The grill is equipped with sensors that monitor the temperature, which is kept at an optimal 350 degrees Fahrenheit. Under these conditions, the ground beef cooks for 40 to 50 seconds on one side before the patties are automatically flipped. This process guarantees even cooking and helps retain the juiciness of the meat. During grilling, the system constantly measures the patty's internal temperature, and the readings are displayed on a screen. Once the patties reach a safe temperature of at least 160 degrees Fahrenheit, they are automatically removed from the grill and placed on special trays that keep them warm at around 150 degrees Fahrenheit. These patties need to be used within 10 to 15 minutes to maintain their freshness and quality. If the time limit is exceeded, the patties are discarded. You see how many precise details go into creating that perfectly cooked patty? The one where the cheese melts just right, just like in the commercials? Right next to the assembly line in the kitchen, you'll find automated displays showing exactly which burgers need to be assembled. This keeps everything organized and helps prevent mistakes. When a customer places an order, the details are scanned, and the information is sent to the kitchen in real time. A multifunctional robotic system assists the staff with various tasks, like gathering ingredients or placing the burgers into packaging. The system is equipped with specialized grips for precise handling of the food, and it uses algorithms to optimize movement, reducing the time needed to complete each task. This increases both the speed and accuracy of the assembly process while lowering the risk of errors. Let's take a look at how these automated processes come together to make my favorite burgers. The bottom bun is placed on a special platform. Depending on the type of burger, automated nozzles apply the exact amount of sauces onto the bun. Next, the patty, which has been kept warm on a heated display, is added. Can you smell that? That's the scent of a dream come true. Fresh vegetables, like lettuce leaves, tomato slices, and onion rings, are added to the patty. And then the burger is topped with the upper half of the bun. Once again, automated systems ensure that each element is placed perfectly. After assembly, I take a quick look to make sure the burger looks just right and that all the ingredients are in place. Sometimes, taste tests are even conducted to ensure the burger meets the flavor standards. Come on, admit it. Who didn't dream of having a job like this as a kid? I know I sure did. Once the burgers are assembled, they are automatically scanned into the system and placed on special trays, ready for packaging. This helps track which products have already been packaged and simplifies inventory management. The burgers move along a conveyor belt and are automatically placed into their packaging. The automated packing machines have mechanisms for sealing the packages, either by gluing or using flaps, and are equipped with sensors to monitor the quality of the packaging, preventing errors. These machines are designed for fast and efficient packaging and can handle different types of containers, like cardboard boxes or paper bags. With the help of these machines, the burgers are placed into branded packaging, which, by the way, is made from eco-friendly recyclable materials. Each burger package has a barcode that verifies its quality. If any issues arise, the system automatically alerts the team. After packaging, the orders are placed into heated display cases, where the temperature is maintained at about 150 degrees Fahrenheit. The packaged burgers are then transported via conveyor systems to the display or pickup area. This reduces customer wait times and enhances service efficiency. The automated systems also keep track of how many burgers have been served, ensuring that fresh batches are prepared in a timely manner. Ever wondered how potatoes turn into the millions of servings of creamy mashed potatoes you enjoy every day? The secret's behind massive factories, from dirty trucks to high-tech machines that transform tons of potatoes into perfect mashed potatoes in just 30 minutes. You'd be amazed at how much technology is hidden behind such a simple dish. I bet you've never thought about what the humble potato goes through. It all starts with the potatoes. After they're harvested, they're transported to the factory by trucks and moved from containers onto special conveyor belts using loading systems. These belts are made from polyvinyl chloride and polyurethane, materials that won't damage the potatoes. The width and incline of the conveyor can be adjusted depending on how many potatoes are being processed. Standard lines can transport around 10 to 15 tons of potatoes per hour. The first stop is the initial rinse. Here, powerful water jets clean the potatoes of dirt and soil. The water used in this step is usually part of a filtration and recycling system, allowing up to 70% of the water to be reused. Eco-conscious practices like these make everything better, don't you think? After the initial rinse, the potatoes move into a brush cleaner. Here, soft but durable brushes attached to rotating cylinders spin at around 100 to 150 revolutions per minute, gently removing any remaining dirt and unwanted particles from the potato skins. The duration of this process depends on the size of the potatoes, with the average potato passing through the brush cleaner in about 15 to 20 seconds. The system automatically adjusts to apply consistent pressure, ensuring that potatoes of different sizes and shapes aren't damaged. Next comes the drying stage. This is typically done using ventilation systems. The drying speed depends on the air temperature and volume, but it usually takes about 2 to 3 minutes. Once the potatoes are thoroughly washed, they are transported to the peeling area. The same conveyor systems come into play, but now with soft rollers that guide the potatoes into the peeling machine. The primary technology used for peeling in large-scale production is abrasive peeling. These machines are equipped with rotating drums or rollers coated with fine-grain abrasive materials. As the potatoes rotate inside the drum, friction removes their skins. The rollers spin at about 200 to 400 revolutions per minute, ensuring the peel is removed quickly and evenly. The speed can be adjusted based on the size and type of potato being processed. The potatoes then pass through high-pressure water jets to wash away any remaining bits of skin. This water is applied with enough force to quickly and effectively remove leftover peel without the potatoes coming into contact with any hard surfaces again, which helps keep them intact. In the final stage, the potatoes are scanned by sensors and cameras. Optical sensors and high-resolution cameras scan each potato, detecting even the smallest imperfections, such as leftover skin, damaged flesh, or defects in shape or color. Any potatoes deemed unsuitable for further processing are automatically removed from the line. You know how much I appreciated mashed potatoes during my freshman year of college? Moving away and adjusting to school left me constantly sleep-deprived and without fail, always hungry. The perfectly whipped and thoughtfully packaged mashed potatoes on the shelves of the 24-hour store near campus took care of my meal dilemmas, leaving me with more time to sleep and study. If I had known back then just how much technology went into making my typical dinner, I would have appreciated it even more. It's honestly pretty amazing. Alright, are we heading to the slicing stage? Since different types of potatoes can vary in shape and size, this step involves sorting with sensors that determine the best direction for each potato, so it enters the correct slicing block in the right orientation. For making mashed potatoes, the factory uses precision slicing machines that can cut up to 50 to 100 tons of potatoes per hour. This equipment is equipped with rotary blades, or special knives, that ensure precise and uniform cuts. The rotary blades spin at high speeds, up to 1,000 revolutions per minute, allowing the potatoes to be sliced into pieces of the specified size in just a fraction of a second. The thickness of the slices typically ranges from 0.39 to 0.59 inches, depending on production standards. This is the optimal size to ensure fast and even cooking. Optical sensors analyze the shape and size of the pieces using lasers or high-resolution cameras. Each piece is inspected as if it were in the palm of your hand. After the potatoes are sliced, the pieces are placed into automated systems that ensure they are evenly loaded into the boiling kettles. The potatoes are loaded into multi-stage cooking units, which allow for processing large quantities of raw materials. A single unit can handle up to 20 tons of potatoes per hour. The potatoes are transported to the cooking kettle using mechanical or pneumatic systems, reducing the time and effort required for manual loading. The entire boiling process takes about 30 minutes, depending on the size and type of potato. The kettles are equipped with temperature and pressure sensors to maintain precise control over the cooking conditions. The temperature is usually set between 200 and 212 degrees Fahrenheit, which is optimal for achieving the right potato softness. Modern cooking systems also include automatic stirring functions to ensure even heating. Rotating paddles prevent the potatoes from sticking to the bottom of the kettle and ensure uniform cooking throughout. To maintain quality control throughout the production process, the system is equipped with moisture sensors, video, and photo analysis. The moisture sensors measure the water content in the potatoes to determine if the desired softness has been reached. If the potatoes are not soft enough, the cooking process is automatically extended. Photo analysis provides a visual inspection of the product. The cooking process is also optimized to reduce energy consumption. By using steam boilers, some facilities can reduce energy costs by 15 to 20% compared to traditional methods. Once the boiling is complete, the potatoes are automatically transferred to a conveyor belt for cooling and preparation for mashing. This cooling process takes place in specialized units that quickly lower the temperature of the potatoes to prevent overcooking. The potatoes are cooled to around 140 degrees Fahrenheit, preserving their quality before moving on to the next stage of mashing. Finally, the boiled and cooled potatoes move on to the next stage, mashing. The potatoes are automatically transferred from the cooling conveyor to mashing machines, which can process up to 5 tons of potatoes per hour. These mashing machines are programmed to adjust the speed and duration of the mashing process. The standard mashing cycle typically lasts from 3 to 5 minutes, depending on the desired consistency. The blade rotation speed usually ranges from 300 to 600 revolutions per minute. Thanks to pneumatic systems, the machines automatically control pressure and speed to prevent overheating and overloading. During the mashing process, other ingredients like milk, butter, salt, and additional seasonings are added to the potatoes. The control systems precisely measure out the ingredients according to the recipe, ensuring a consistent and uniform flavor throughout the batch. The freshly whipped mashed potatoes are transferred to an automated packaging line. At this stage, the temperature of the mashed potatoes needs to be between 160 and 175 degrees Fahrenheit to prevent condensation inside the packaging, which could lead to spoilage. The mashed potatoes are typically packaged in various formats, with containers ranging in size from 1 pound to 11 pounds. The packaging machines store data on different container sizes, allowing quick adjustments to meet customer needs. The containers can be made from plastic, glass, or eco-friendly materials such as biodegradable plastic, paper, or recycled materials. The mashed potatoes are automatically dispensed into the packaging using dosing pumps, which control the exact amount of mashed potatoes for each container. Filling a standard 1 kilogram container takes about 15 seconds. The packaging line can operate at a speed of up to 1,200 containers per hour. Now that's some serious speed. The filled containers go through an automated sealing system that prevents air and bacteria from entering, which could spoil the product. Heat shrink films or tightly fitting lids are used to ensure the long-term preservation of the mashed potatoes. The system automatically monitors the seal's tightness to prevent any packaging issues. Each container is also labeled with product information, an expiration date, and nutritional facts. This is done by automated printers, ensuring the labels are clear and accurate. The labeling systems can handle up to 200 labels per minute. After packaging, the containers are automatically transferred to cooling chambers, where the temperature is maintained at 40 degrees Fahrenheit, helping to keep the mashed potatoes fresh. The cooling process takes about 1 to 2 hours before the product is ready for shipment.